All right, welcome everyone. It's 1:40, so we'll get started with our last ITS Friday seminar of the quarter. I am very pleased to introduce Dan Chatman, who's my PhD mentor. Dan conducts research on how transportation systems and land use shape travel behavior, economic opportunity, and urban equity. He's done a lot of empirical work on disentangling built environment effects from residential self-selection and congestion, price parking, and transit-oriented development, which I'll talk a little bit about today, I think. Telecommuting, e-commerce, post-pandemic travel, anything between the built environment and transportation, Dan has probably done. He is professor and chair of the Department of City and Regional Planning at the UC Berkeley's College of Environmental Design and faculty affiliate at Berkeley ITS. So without further ado. Yeah.
Thanks. Hi, everybody. Good to see you. I'm happy to be here and glad to finally be in this storied building, all the pictures on the walls, all the people, all the historical figures. Sorry, I'm just making fun of the pictures. I'm going to be talking about a project. I'm going to be focusing on this particular question. It's sort of a more provocative version of the question that is the larger project from which this is drawn, which affordable housing projects in the state of California reduce VMT. But really the research I'm presenting today comes from a project that was funded in large part by the California Air Resources Board under a contract entitled Assessing the Quantification Methodology for the Affordable Housing and Sustainable Communities Program. And I want to thank Julia Branco and others at CARB, including Nicole Enright and Mario Cruz, who were involved with the contract management for this project. And a lot of people have been involved with it. I was the PI on the project. Breitling Snyder was a master's student, so was John Atkins. And Kiran Patel doing a bunch of work, a lot of the data work that I'll describe briefly, and also a lot of the kind of the exploratory regression analysis that I'll be presenting some of. Marlon Bornett, Sieva Rodnansky, and Andre Commendon. So Marlon and Andre are at USC, and Sieva is at Occidental, and they were involved with the project as well. And so it was a fun project, actually, and it's done now, although we're going to be talking, I'll talk at the end a little bit about some extensions to this work that'll be ongoing for the next couple of years, including some folks here at Davis. So a little bit of background. The Affordable Housing Sustainable Communities Program, AHSC program, includes a portion of the kind of project proposal evaluation involves estimating how much a project proposal is supposed to reduce VMT. It's supposed to be a GHG reducing program. And so proposed affordable housing projects are scored partially on how much they ostensibly reduce greenhouse gases via their reductions in driving. And so the California Air Resources Board sponsored a research project to try to look at improving the calculator that was being used that had been recommended by CARB to be used for project proposals to estimate the VMT reductions. And I'm going to read some text from the HCD website describing the AHSC program, or I guess people call it ASIC. I'm not good at using those acronyms like that. But the ASIC program provides grants and/or loans for projects that achieve GHG reductions and benefit communities across California, particularly low-income communities and low-income households, through increasing accessibility of affordable housing, employment centers, and key destinations via low-carbon transportation. These investments result in fewer vehicle miles traveled through shortened or reduced vehicle trip length or mode shift to transit, bicycling, or walking. So the premise of the program is that it's supposed to be doing this. So that's what we were doing some research on, was trying to figure out both directly and indirectly, what do we think the VMT reductions are, in what contexts, under what circumstances, in which places, which sorts of projects. So it was the goal was primarily to estimate how HSC projects and affordable housing projects more generally, and people who are of lower income more generally, because we have these different comparison groups you have to think about here when looking at data, are likely to be affected by this program, how much VMT variation there is according to these sorts of characteristics, and how could we relate that to the program. And then we also evaluated the current CARB VMT reduction calculator, and we recommended changes to it to focus. And I'm going to give away some findings a little bit in the beginning, and then come back to where they come from. But one thing that we have recommended is that the calculator needs to focus on larger scale built environment measures. And so I'll get into that a little bit. And then I'm going to be talking for a little while about something I'm going to call the counterfactual to the project, because part of the question as to whether we have state programs. They are intended to reduce how much people drive. The question is, what effect does the program have? And to answer that question, you have to figure out what would have happened in the absence of the policy or the absence of the program. And it turns out that answering that question is not straightforward. And so that's part of the trickiness about this research question, and as it applies a fairly well-known set of empirical results to a method in practice. So a brief overview of the existing CARB calculator. There is a baseline so-called unmitigated VMT, which is based on an average of average simulated trip length for the county in which a project is located. So there's a number. It comes from a model, and that number is the baseline VMT that any project proposal located within some selected distance of sufficiently high level transit is said to be reduced from. Okay. The method uses site level so-called affordable housing inputs, which are assumed to reduce VMT from this baseline. And then it also includes one neighborhood level characteristic, which is employment density in the census block group. And elasticities and reduction caps are cited from the 2010 CAPCOA quantifying greenhouse gas mitigation measures report. And so there's a lot of issues that were identified by CARB, which was the basis for the project in the first place. So CARB said, well, we know that there may be some limitations to this method, and so I'll get into that a little bit when we talk about what we did. But I will say here that, coming into this research project, there were a couple things that became immediately clear when we looked at this method. One of them was the assumption that only reductions could happen from a project. The second one was the assumption that whatever would have happened would have been equivalent to some county average. And the other thing was the assumption that parcel or site level characteristics were the most important factor in determining the extent to which there could be a reduction in driving. The literature on this topic has really not very much even considered site level or building level characteristics. And the reason for this is partly just data availability. It's partially, we don't really have a lot of information typically in the data sets we have access to about building level information, but it's also because the theory around why we think the built environment influences people's travel doesn't have to do with the characteristics of the building they're in, so much as it has to do with the characteristics of the things around them in their environment and their neighborhoods and so on. So for example, we understand this literature to tell us that the reason that higher density gets people to drive less is because when there's more stuff near you, you can get to it via something other than a car. And because there's this literature that suggests that maybe it's harder to drive in those places, right? But that's not about the building, it's about the neighborhood. So we knew coming in that we were going to be looking at, and CARB already knew that there needed to be an additional set of neighborhood level characteristics, and they just wanted to get us to look into that and to figure out how to translate that into practice. So here's what we did. We did several things, and I'll talk about some summary findings on the next slide. But the main two things that we did, or the main three things that we did, first of all, we measured block group level, and I mean by block group level, I mean aggregated travel activity over time using cell phone data from 2019 to 2024. In other words, we got access to a data set that enabled us to understand origins and destinations from cell phones that we could translate into estimates of travel. I'll get to that in a second, but and we looked to see how that was perturbed or affected by the development of known housing projects in those block groups over that period of time. So we were really excited about this going in because we thought this is really cool. We're going to be able to look over time at the same block groups and see as a new housing project comes in, what happens. And I'll talk about why this completely may have failed. Although we have some findings that came out of this, interestingly. They are a little hard to interpret, but I'm going to talk about that. I may make the mistake of referring to that as task one because this was a CARB contract, so we had tasks. You know, for those of you who have worked on one of these things, you had your tasks and your deliverables and all that kind of stuff. And so that was task one. Task two was estimating household level VMT using survey data, using the NHTS, the National Household Travel Survey, and estimating that as a function of built environment characteristics and transit access and other sorts of things around the state. We did that for the whole state. We did that for 56,000 households. And that was called task two. And this was the thing that kind of reinforced the literature. And task one ended up reinforcing the literature in a similar way. And then we used those estimates to create a sort of a proposed new method to forecast VMT variation in general, but also VMT variation specifically associated with proposed affordable housing developments. And when I say proposed affordable housing developments, what I want to make clear is that in the end, we're always using kind of approximations of data, and we don't have survey data from affordable housing development. But what we do have is survey data from people who are below the 60% of median income. That would be the typical requirement for people to qualify for living in affordable housing. And so we can use that as a way of understanding how the built environment affects the travel of people who are eligible for affordable housing. And by the way, I want to encourage anyone to ask questions. I'm happy to be interrupted. I prefer to be interrupted. And so questions come up on the thingy. You can on the Zoom. Okay, so I'm going to give you our summary findings. And first of all, I'm going to say, look, we had all these tasks, and two of them I haven't really even mentioned. So the first one is, do AHSC projects reduce per capita activity within neighborhoods using before and after origin destination data from mobile phones? That's the first question. The second question, what is the difference in VMT per capita based on these locational factors? This is a more conventional built environment study, built environment and travel study, similar to that's been done in previous literature. And then we were also asked to answer a couple of other questions having to do with how does unit size impact household auto use? There was a request from the community to CARB to consider the possibility that larger households might have more efficient use of vehicles, that they might have more sharing of vehicles, and you get some economies of scale in household sharing of household responsibilities. And so maybe there's an argument for giving credit for larger houses to have less per capita travel. And then we also had a similar question about age-restricted buildings. Is there a reason to believe that we should use different factors for age-restricted buildings? And so the answers to these questions are, first of all, we found that these projects, whether they were in low VMT or high VMT neighborhoods, did not significantly change travel in the surrounding neighborhood, meaning that the building level characteristics did not cause VMT to vary very significantly in comparison to the neighborhood in which they were found. I'm going to come back to this because what this really can be interpreted as is the characteristics of the neighborhood are the important characteristics, not the characteristics of the building. Yes, Gil.
A quick question on the baseline, maybe I missed it. So more or less VMT compared to, okay, if this neighborhood was built on a green field, so the field had 0 VMT before. It was
we only had, yes, thank you. We did census block group level aggregation. And so we didn't have any instances, or we had to throw out any instances where there was 0 residential development in the neighborhoods prior to the advent of a new housing development.
But you're not asking if the people who move there now drive more or less than what they drive before, regardless of where they move from.
No, what we're looking at, you're right, what we're looking at is before and after in the same locations. What we're not able to do with these data, I'll talk about this maybe if we have time, is to actually follow before and after data of people who moved, right? That's not what we have access to. We've got cell phone data that is not following the same individuals over some long period of time, but that's what we would need to do that. Instead, what we've got is we've got a snapshot of cell phone data from people who are known to live in these census block groups.
I guess.
Yes, question.
Related to that, I was curious about how you would differentiate activity types with the cell phone data, and were you able to differentiate it, meaning like,
No,
so like, do you know if they were, because you're measuring
No.
activity, so how fast they're going or something?
we didn't differentiate any activity in these data. It wasn't possible. These are the advanced data. I'll talk about in a second, data in a little bit in a second, to get into that a little bit, but we were not able to reliably get speed from this. And it turns out, so I'm working with someone now who works with phone data, Marta Gonzalez. It turns out all of the phone data that some of you may think you have access to, it's mostly fictional.
It's already, yeah.
Okay, well, we'll get, and there's also a problem with the sampling rates gone down to less than 1% or whatever it is these days, but it's low. So I'm going to come back to this, but the point of this is to say that what we found was, there's two ways of interpreting what we found. One of them is, well, the data were not as good as we thought. That's one possibility. And the other possibility is, well, affordable housing projects in these census block groups do not seem to have much of an impact on average travel. And we think that same finding actually makes a lot of sense if the most significant impacts of travel are neighborhood level characteristics and not building level characteristics. Okay, so, but I'll come back to that. The second big question was, what is the difference in VMT per capita based on a variety of locational factors? And the answer is, well, a bunch of them are correlated, and the ones that are some of the most important are rail station access, which I don't agree with, by the way, but it's the finding, so I have to report it. But I'll talk about that in a second. Something called network load density, which I will describe, regional employment access, street density, things like that. And we come up with some estimates, and we come up with VMT variation associated with the built environment that come from that model. And then parenthetically, we didn't find anything going on. Oh, look, in fact, it's so parenthetical you can't read it. This says we found no evidence that larger units are associated with lower VMT per capita. And also, we didn't find any evidence that there was significant differences among low-income seniors as compared to the rest of the low-income population. So we didn't find any evidence that there should be separate factors for the senior population. I have this note here about task one, which I may need to come back to. What we did is we did pre-development and post-development activity levels, and we compared changes to control groups, and we did regression, discontinuity, and difference methods for that result. So I just want to show you the data that we used.
Can I interrupt with a question?
Oh, yeah,
You'll
please.
answer this now.
Yes.
So Darren Conley asks, regarding affordable housing developments don't affect neighborhood activity. Well, he asks, will that effect depend on the size of the development versus the size of the block group? So for example, a small development in an already highly populated block group should have less effect than large development in less populated block group.
Yes. The answer is absolutely true. Yes. However, we looked for that. We couldn't find the evidence. So we were thinking, oh, okay, if it's a really big development and it's a relatively small population census block group, we should be more likely to be able to see a perturbation in the activity. But we didn't find it. We didn't find it when we looked for it. So, but that's absolutely right. You'd expect any effect to actually be magnified depending on the size of the development. If it's a really big development, it should have a really big impact on the block group. We didn't find any evidence of that. Here are the data sources. A bunch of data sources for both sides of these two tasks, right? One of them is this block group activity level panel cell phone data from Advan. This other one is the dependent variable is household VMT, and actually it's per capita VMT, and it's per capita VMT controlling for vehicle occupancy actually. And we have a lot of different variables that we're trying to control for. On this side, we're looking not just at AHSC projects, which I'll show you a map of in a second, but we're also looking at CoStar data on market rate multifamily projects. And we're looking at other data that give us affordable housing projects that are not sponsored by AHSC. And so we looked at lots, and we have some results that come out of that I'll talk about next. And we do a little bit of controlling for characteristics of block groups. We tried to see whether or not there's any interaction of the presence of an AHSC project or a market rate or a affordable housing project with any other characteristics of the neighborhood that might give rise to a smaller or larger impact. And we didn't find much to mention on that front either. And then using the survey data, which was the NHS data, the National Travel Survey data from 2017, we spent a lot of time coming up with a lot of different built environment measures that we ended up summarizing to the block group level so that it could be used by the state in actually estimating these going forward. And we used data from the Longitudinal Employment Household Dynamics data set via the EPA 2017 data set. Same thing for population density. We used the EPA data set, although those data actually come from the American Community Survey. Street density for OpenStreetMap, intersection density from OpenStreetMap. Network distance to the nearest rail stop, employment accessibility within 45 minutes by car and transit, although actually that's a typo. It's only by car that ended up being, it's not a typo. It's only the car variable that ended up being significant in the final model. The accessibility ratio, the ratio of transit to car accessibility, bus stop density, which we spent so much time calculating, because it turns out to calculate bus stop density is a project of weaving together more than 100 agencies worth of bus stops, and they don't represent their bus stops the same way. So it was a huge problematic thing that we spent way too much time on. And then a bunch of demographic controls that come from the survey itself. So and what we did there is we looked at lots of different scales, which I'll show you a picture of in a second. So for task one, the AHSC project database is shown here. That is to say the geocoded map and our, oh wow, it really didn't come out at all. It's weird. Like you can't see anything. I wonder if that's going to keep on happening for the maps.
Yeah, it is there.
Oh, it is?
We are losing some colors on this project.
Oh, okay. Okay, well that may bring things to a close much faster than I was hoping. I would like to know if that's going to happen. So let me just take a look and take a look at that map right there. Oh, that's not terrible. Okay. All right, you get the idea. I can sort of talk about those maps. Unfortunately, yeah, you're not being able to see it as much as I would like it. What about this? That's okay. All right. Okay, but this one you can't see. This is a state map of the state of California. You're laughing, but it is.
There's LA.
You can kind of see. You can kind of see. This is the map of the state of California. So we identified about 85 HCC projects, and there was a lot of work done to try to identify them all because there wasn't a good database available, and some fraction of them had completed transportation elements as well. Average number of 89 units. Number of units range from 23 to 336. Sorry, 326. This is the location in the state. This is the location in the San Francisco Bay Area right here. So San Francisco is there, and Oakland and Richmond and so on are up to the right. This shows the number of completed projects that were entirely residential versus those that had some sort of additional transportation component to them. And then this shows as well. I'm sorry, actually, this is a subset of that. My bad. So it's 85 total that we were able to geocode and find complete information on of HSC projects. There were about 1,000 market rate projects. There are some market rate buildings that are mixed and have some affordable units. We can't control for that in this data. And then we had about 353 affordable projects that were not AHSC projects for task one. And let's see, what I'm going to summarize for this is to say that, interestingly, we found evidence that market rate houses, because there was a bigger sample size, had an incremental reduction in VMT, but we did not find that for the HSC projects, although the sign of the coefficients is about the same. So part of that just might be the size of the sample. But on the other hand, we did some other tests that suggested that it might not be that at all. It just might be too much variability in that. So I don't have first of all, I was not the lead on this part of the work. And so you may have questions have to do with it. There are technical questions about the way that we controlled for lots of things. For example, the number of devices in each census block group, which we did control for. But long story short, we didn't find much going on that we could point to confidently to say that there was anything associated with activity levels and AHSC projects, whether they were having transportation or not. There are a couple of other statistically significant results here, but I can't go into the details as to why we're suspect about them. They have to do with the fact that we're controlling for county level average deviations instead of doing an absolute number there. So that's sort of giving you some sense of the overall effect of the projects within the census block groups. I need to emphasize one last time, because this is something that's been coming up within CARB. This finding does not mean the AHSC program doesn't work. This finding just says that the AHSC program probably works via the placement of projects, not via the characteristics of the buildings. Okay, and I'll emphasize that again. So for task 2, we used the National Household Travel Survey of 2017. This map also shows California. It's a lovely map. It has the mountains are in there, the ocean is in there, the plains are in there, but all you can see is a bunch of dots. But what this shows is it's a dot density map. So for those of you who are like data people, you know these are not real household locations. These are just scattered household locations because we are required to use the confidential form of the data that we got access to is via a remote data center. We are not allowed to show or export household locations. We worked with household locations in the remote system, but it's a confidential system that the NHS can be accessed via. And so what this shows is just an interpolation of household locations. So for example, for LA County, actually most of the households are going to be clustered more centrally in the urban areas, not just scattered randomly throughout the county. About 56,000 observations that were under 300 miles in the travel study data that we used. And then we did a bunch of, as I said before, or as I alluded to before, but I'm going to get into a little bit more now. One thing that we really tried to do a good job of in doing our estimates is to add to the existing fairly large literature on this topic, is to really go to town with scale. And so what we try to do is to represent different scales of built environment measures, as well as to interact them with each other. We did some machine learning stuff, which I thought I would never say, but I did a little bit of with John Atkins' help, and we ended up kind of throwing that stuff out because it caused problems for us. But so we calculated most measures at 4 different scales. The census block group of the home, right here, a half-mile radius that captured all of this block groups whose centroid fell within that radius. So in this case, it would be those 3. This is the mile radius. This is the 2-mile radius. And long story short, it turned out that the 2-mile radius stuff was really more important on average than the stuff that was measured more locally, on average, not for every measure. And for some time, research has shown that built environment characteristics such as population density, road density, and so on, if you want to look at what matters, you want to look at a larger scale. And in fact, there's some evidence that suggests really the metropolitan scale might be even more important. And we didn't go to that extent, except that we do have these 45-minute measures as well. So we did a lot of interactions and a lot of exploration. Looking at I never did do my timer. How am I doing?
23 minutes.
23 minutes left. Okay, great. So then we got some results. And what we did is we had a set of more than 100 built environment variables, not counting the interactions. And then we ended up getting it down to a parsimonious set of around 10 that were significant. And then with a whole bunch of socioeconomic variables, the normal ones. I'd be happy to answer questions about that. I'm just not going to talk about it right now. But that gave rise to some results. And so I'm going to show you 3 kind of graphs of results. One of them is this one. This is cross-sectional results from the NHS with the full sample, not looking at differences between lower and higher income people. This is just the whole sample and coming up with the best model that fit that. And I will go through the variables that ended up being significant in the model. There are some other variables that are included in this model that are not shown in this particular graphic. And the first one is net load dense or network load density. And this is a term used to refer to the following measure. Take the employees in a place, add together with the employees with the residents of that place, and divide by the road length or the road capacity. That's network load density. What is it meant to represent? Well, you could say it does not, if you're a machine learning aficionado, you could say it's not meant to represent anything. We don't really care what it represents. But I can't say that. So what it's meant to represent is potential traffic. It's meant to represent the potential congestion in a place, which makes it less likely for people to want to drive and maybe more likely for them to want to use other modes, and also may be correlated with some other things. It is definitely correlated with some other things like population density. Network load density at the 2 mile radius is our largest and most significant coefficient. What's going on with these coefficients? For those of you who are paying attention right now, these are standard deviation coefficients. You think of them as the equivalent of z-scores. In other words, for every standard deviation increase in network load density, the number of VMT per day goes down by about 1.9 miles. In these data, the average VMT per capita is around 19 to 20. So this is a fairly large decrease. It's approaching, let's call it an 18%, sorry, a 10% decrease. It's approaching a 10% decrease associated with each standard deviation change in network load density. And similarly with the other coefficients here, that's what these refer to, except for has real axis, this is dummy variable. And this is the one that I'm unhappy about, that I don't really believe, but it's in our data, so I have to, just report it. I'm making a joke because in fact, this is just a bunch of math, and that's what I'm reporting. It's a bunch of math. So that having real axis within a quarter mile radius is associated, and that's on the network, is associated with a 3.6 mile per day reduction, which is quite large. The density of bus stops, each standard deviation is associated with a reduction of about 0.65 miles per day. Street density associated with 1.1 mile reduction. Retail density, each standard deviation associated with about a half mile reduction, and so on. So you can see all these things together. And then finally, you have these right here. And by the way, the color of the bar is also the level of statistical significance. One reason I'm not happy about this is it's not very highly statistically significant. So I'm questioning whether it's really true. I think this is actually probably mostly parking, but I don't have parking in the data set, so I can't actually measure that directly. These two are actually quite highly significant. This is jobs within 45 minutes by car. Wait a second, why is that negative 1 mile? Well, the trade-off is not having so many jobs. Having more jobs within 45 minutes by car means having more opportunities that are at least that far away as opposed to farther away. That's one way of interpreting it. This ratio of transit to car access is just the number of jobs within transit divided by the number of jobs within car by 45 minutes. So the better the transit does competing with the auto, the larger the reduction in VMT. So all these things together have the potential to be relatively large effects. We don't have to even get into you don't even have to argue about these or get into the details here as such. The results are not all that dissimilar from other literature. What's different here about this is that we've got them applied to current California data across the state in a way that enables the built environment data to be updated to present day conditions to give us present day estimates of built environment related VMT variation, as opposed to a form of VMT variation that doesn't account for socioeconomic characteristics. So part of what's happening in the state of California right now is we have things like the replica data that are being used to ostensibly predict VMT, but the replica data don't control for socioeconomic characteristics, so they don't have an implicit counterfactual embedded in them at all. So that's an issue. Anyway, so I will come back to the counterfactual idea. And so then I had some other results as well. I'm going to skip over this one, and I'll get to this one, and I'll say these are updated cross-sectional results for low-income households, and it turns out low-income households are significantly different from the rest of the population when it comes to two coefficients, street density and network load density. long story short, oh, by the way, now you can't see the colors, so sorry about that. But network load density is the most statistically significant and the largest impact, other than having rail access within walking distance, 0.25 miles, which again is lower significance, but still large. And then we have these other, so there's some variation here. And what we've done is we tried to embed those. We have embedded those into the calculator that we're kind of putting forward as a possibility to CARB for their consideration right now. So those, what this model showed, and when I say it's updated, I guess I won't get into the details, but basically we did a bunch of post-project work that was funded by ITS to fix some data problems, to exclude some observations from the data set, and to control for the truncation issue that arises when you have a Tobit model with a left sensor dependent variable. So very technical issues that came up that we were trying to resolve there. So those are the results that we then need to figure out, okay, if we think that these results tell us the VMT variation associated with built environment characteristics associated with each block group in the state of California, what do we do next? How do we can translate this to some sort of an alternative calculator method for the state to use to tell the affordable housing proposal bringer, this is how much you are going to reduce VMT for this project. And that gets to the issue, what we're calling the counterfactual problem. So the counterfactual problem, I've already said, this is what's done right now is there's a number from a county model, and there's an assumption that there are these rules that you apply that if you have this characteristic of your building, like let's say it's tall, and let's say your building has a shop on the ground floor, and let's say it has some other things, then you get to have a reduction in that VMT. You're giving credit for that. And so what we're proposing is something else, something that is more directly empirical, but we still have the problem of saying, okay, well, what would have happened in the absence of the ASIC program? In other words, what is the ASIC program doing? What is it doing? So what the ASIC program does is it provides funding to some proposals for affordable housing. The question is, what would have happened if the ASIC program didn't exist to that particular proposal? One answer is it could have been developed exactly as it was in that same location. And if that's the answer, of course, the impact on VMT of the ASIC program is zero. That's probably not what the impact of the ASIC program is. It probably does make an impact. The question is what that impact is. So one question is, what would have happened if the ASIC project wasn't built? Another question might have been, what would have happened if the project proposal were not funded, right? We're not really answering that question. I'm just throwing that out there as a problem that we have. We don't really know what would have happened in the absence of the program, and therefore we don't really know what the impact on VMT would be. However, we can make some reasonable guesses. If we think that the program is about ensuring that housing is developed in certain locations, then we just have to assume something about the average location of other projects, or let's put it another way, the average location of housing projects in a housing market. Okay, so setting that sort of that philosophical issue aside, what we wanted to do is to use the same model that we created at the block group level to come up with an average VMT for some counterfactual area in which the housing would have likely been developed. And there are three possibilities for that. One of them is, okay, let's assume California's state housing growth is a state phenomenon. So any particular housing unit, we're going to say, okay, fine, that's the housing unit that we're proposing and that we're funding. And if it wouldn't have happened there, let's assume that the statewide average would have been the result for the VMT of that housing project somewhere else. Why the statewide average? Because the average location in the state has the statewide average for the most part, right? If you're focusing on the neighborhood the components of VMT. So what we did is we came up with a weighted statewide forecast. When I say forecast, what I mean is the predictive outcome of this model applied to the whole state. The predictive outcome of the model applied to the metropolitan area in which the project was found, or for fun, we decided, okay, well, look, we could let's try a 10-mile radius. Let's assume the project was built there, but if it wasn't built there, the housing or the people, anyway, who would have lived in the housing, would have lived somewhere else in a 10-mile radius. And so that's where these maps come in, because what this map shows is 10 minutes great, is the VMT variation associated with built environment variation roughly centered around 0 for the state of California. What do you notice about this? Well, the blue colors are the places where there is a reduction from the statewide average. The orange and yellow colors are the examples of the places where the average VMT exceeds the statewide average. What you will notice about this is that the vast majority of state exceeds the average. The reason for that is because this is population weighted, right? So obviously the people who have a lower VMT are in the places where people don't have to drive as much. Okay, that's pretty obvious, right? So then you would say, okay, then all AHCC projects should be in these blue areas, right? But another way of thinking about this is, well, what if housing markets are metropolitan? And then what if the housing would have been developed elsewhere in the metropolitan area? In that case, we created a CVSA counterfactual, which looks slightly better for some of those areas. You see a few more blue areas. Why are the little blue areas there? Because the argument here is that whatever would have happened in the absence of the program wouldn't have been the average state number. It would have been something that would be more average for that metropolitan area. So a couple inset maps. This is Los Angeles VMT variation with a CVSA counterfactual. It's not the LA CVSA. It's actually, I think, 3 CVSAs here. And what you see is that you have areas like Riverside getting some blue and light blue, because the assumption is that the housing market for that area isn't the entire CMSA, it's a smaller area. And so, but what you also notice about these maps is they're smooth. Do you see there's not a lot of speckling and variation there? The reason that there isn't is very simple. 2-mile radius and 45-minute accessibility don't vary very much from block group to block group and are highly predictive of VMT. So with this kind of, and of course there is some speckling here, right? But the point is that there is less than if everything were based on the characteristics of the parcel. It's not all about the characteristics of the parcel, it's about your surrounding environment. Similarly here, this is Fresno VMT variation that's with a CVSA counterfactual. And there's an example of San Jose, 2 projects in the San Jose Metro. One of them is in block group A, one of them is in block group B. For those of you who are in does anyone know where that is? It's a fun game. You're from Davis.
Almaden.
No, Almaden is actually way farther over there. This is, I think, Morgan Hill. Gilroy's a little bit farther south.
Oh.
Yeah. There's a rail station there. TUD. What this shows is that, for example, if you look at the VMT estimate contribution of all the characteristics of that block group and the surrounding block groups, you get to a negative 3.75 miles per capita per day estimate for VMT here in comparison to the metro area. But here you get an average of 6 miles more per day for that particular location compared to the CVSA. It looks a lot different if you do a weighted average around a VMT around a 10-mile radius. Unfortunately, again, you can't see the whole map here, so apologies for that. There's a lot of blank areas here because the 10-mile radius just doesn't work in places that have large block groups. If you only have one block group next to you, it just doesn't, the math doesn't really work out. So this is spotty because of the 10-mile definition. This is the Bay Area, and this shows the difference between the 10-mile radius version and the CVSA version. So if you believe the counterfactual is a 10-mile radius, you have different decisions, you have different beliefs about where there is a reduction in VMT than if you assume that the metro area is the right unit of analysis to understand housing production and alternative housing locations. And then then the argument shifts to that. I believe the CVSA argument more than the 10-mile radius argument, but Breitling wanted to program that, so I was in support. So the kind of the punchline here is that the vast majority of ASIC projects, according to this calculator, reduced VMT. They're mostly blue and light blue and dark blue, but some of them didn't probably. At least I don't think they did. Or I would say the math suggests that they have averages that are higher than the CVSA average, right? And this accounts for rail access, by the way. So this just shows you that it's the same color ramp as I was using before. So the greens are kind of in the middle. So the greens are the ones that probably didn't have much of an impact on VMT. The ones that are orange or yellow are the ones that are likely to have increased VMT, and the ones that are blue or light blue are the ones that are likely to have decreased VMT in comparison to the metropolitan area of which they are a part. And we're at 5 minutes, which is perfect. Okay. And so you can see this is a little inset map showing it for LA and the San Francisco area, and you see a couple of examples in the Bay Area where there are some locations that, according to these calculations, are above the median VMT, the average VMT for that CVSA. And so this suggests that the housing project shouldn't have been built, because the housing project could have been built for other sorts of reasons, but that the housing project is not likely to be VMT reducing. Similar thing here, this is Fresno and includes Baker Fields. You see some examples of ones that are probably VMT increasing. And then this graphic just shows the VMT variation, assuming CVSA as the counterfactual for ASIC projects that were funded, the 85 or so that we have data on. And we have, the vast majority of them are in the negative range, but some of them are in the positive range. And well, that was the purpose of trying to update this calculator, is to come up with better estimates. And so that's what we're hoping that it does. So the summary of the presentation, we're suggesting that the forecast can be made more accurate by using these larger scale built environment measures. We've provided a spreadsheet tool that might be possible for the state to use, and that's sort of under review, and we're going to see where that goes. I forgot to mention the most important thing to say about the site level measures, which is that we're not able to conclude off-street parking availability, but the literature suggests that of all of the parcel level measures or the site level or building level measures available, parking is super important. And in fact, parking might be more important than all of those other neighborhood level built environment variables. So it needs to be included. The problem is how to do it empirically and how to quantify it correctly. But in the absence of doing that as part of this project, our recommendation is the state should continue what it's doing, which is to give a fairly large credit for VMT reduction to projects that have lower parking ratios. And then we have this problem of adopting a different counterfactual, and at the very least seeing the possibility. Just because something is proposed under the ASIC program doesn't mean it necessarily reduces VMT. Some of them may in fact increase VMT. And this is my last slide. So we have a project that we expect to be starting in May or June with Mark Gonzalez at UC Berkeley and Mike Manville at UCLA, Susan Handy, Amy Lee, Jamie Volker, Elisa Barber at UC Davis, which is ITS funded via a state allocation of funds to the 4 ITSs in the state, which is to find a bunch more examples of state endorsed or state level or regional level estimates of VMT mitigation associated with the project. So this is the cottage industry that's sprung up in the last few years, and to try to figure out how to use examples and find other examples of classes of project for which we can improve the estimation procedures and think through what the issues are in terms of practice. Marta does a bunch of work with phone data, so we're going to look at phone data and GPS traces, and there's a lot of issues around that she's very familiar with. We're hoping to look at odometer data, so Gil, I'm going to talk to you later, and road counter data, and then we're hoping to also do a better job with built environment measures and to look at least 2 use cases. One would be a transportation use case that's intended to mitigate VMT, things like bike lanes and so on, with actual data. And then some other use case that's a land use case, and it could be housing more generally as opposed to affordable housing, for example, for an improved calculation method. So I'll stop there, and I'm right on time. Right? Okay. And happy to talk about it and take questions.
So I have a couple of questions on that, so before I forget. One question from Darren again is about rail access. So are you differentiating between frequency of the rail service at those stops?
No, so yeah, so we're just doing rail access. We think, there's so much variation and obviously levels of rail service and where it actually gets you. And the fact that we don't makes it that much more interesting that we're getting such a large coefficient. But we are controlling for generalized transit accessibility with the 45-minute jobs ratio. The 45-minute jobs measures, those isochronic measures have been shown to be very highly correlated with more sophisticated gravity-based measures. So I'm happy with those accessibility measures, the transit 45-minute jobs by transit. And also we have the bus stop measure. So we have 3 measures of transit access all at once. My experience with the bus stop measures has been that that's pretty highly correlated with transit service in general, including rail service. But we do not have a control for that. It would be difficult to do given the nature of the data because we have so few observations near rail. Part of the issue with the data is that you look at the 55,000 households in the California, in the NHTS, the California add-on sample of the NHTS in 2017, I think maybe 350 of them are within a quarter mile of rail of the 55,000. So you have a problem trying to differentiate between types of rail with the sample size. And so that's sort of a systemic problem, but that's a great question.
There's a second question. Does the VMT model differentiate between affordable rental versus owning and affordable multifamily versus single family?
Yeah, so no, it does not. Yeah, I don't have a theoretical reason I'm not sure why I would do that, but there might be a reason. But I probably should write that down. Are those written down? I get them afterwards.
I can, I don't know where they get saved.
Yeah, no, we did not look at, so the question is, yeah, do you look and see whether or not people who are both below income and are renting versus those who are both below income and are owning or somehow different from each other? My guess is in this data set, we probably don't have enough of the below 60% of median income who are owners to actually influence the results very much, but I haven't looked at that. So, are you writing it down for me? I feel bad. Like, I'm too lazy to write it down myself. I don't have something to write with right now. But thank you for that question. Interesting question. Other questions? Yes.
You also mentioned other data things. So like in terms of like the phone data, like what were some of the problems that you're running into that you didn't want to get into at that time? And then when it came to the bus stop density.
Okay, that's a quick question. We'll just go over that one. Okay, what's the next one?
Sorry. The next one is also the bus stop density thing. Because for other projects, I've also had that problem where multiple agencies will use the same bus stop. You don't know like if it's the same bus stop or not. And
oh, that's just one of the problems, honey. I mean, we had like 15 problems.
Okay.
So the GPS, the GIS files that are created have completely different conventions about how they represent everything. So for example, one agency might say, we have one point representing every time a bus stops at the stop. Another one might have one point for every time a bus number serves a stop. Another one might have just one for each stop. Another one might have one for each stop, regardless if it's actually on both sides of the road. And we had to literally go through all of these. Oh, and the problem was that we were using 2017 archival historical data, and that made it that much worse because we had to go through all these different agencies to find these. Actually, it was Sieba Brodnansky had accumulated a whole bunch of these files. So we started there, and they were all from around that time, which was great. And then we had to go find a bunch of other files. It's going to be easier. At some point, we're going to be able to just do GTFS for the whole thing. And I think the way GTFS represents things, at least will be consistent. We were just looking for consistency because we didn't want to conflate the way that one agency is representing its bus stop data with meaning somehow higher density or lower density than another agency just because of the way it represents its data.
The GTFS is not much better. It's just the evil you know versus the evil.
I think it's, this was so bad that I'm sure it'll be better. We actually have started looking at it, and it is a little better, but it turns out data is not good. Yeah, data is a problem. Yes.
About data.
Yeah.
Like, can you tell us more about like how you aggregate it? I think you mentioned it's in some places that it's per day. And like which day is it aggregated the VMT data, the phone data?
The phone data. Okay. The phone data are aggregated on a monthly basis. So we had a monthly panel. That's how we did the work. And so we did a whole bunch of testing of lags, 2 month, 3 months, 6 months, 1 year lags. So there's a lot of testing of that. Like and this was all, I mean, I contributed conceptually, we had lots of conversations about it. This was a 2-year project, but it was mostly Andre and secondarily Sieva who was doing all of that work. Lots and lots of testing of different possible specifications of these things. Yeah.
And I guess related to that is because then, since it's not easy to define in which mode they were traveling, do you think it's kind of capturing more like personal miles traveled instead of vehicle miles traveled?
Yes, thank you so much. That's a great question. So you've noticed something, which is that I never said these were vehicle miles traveled. I said this was activity distance, right?
Yeah.
And so to the extent that there is significant failure to capture modal differences between census block groups, you can say, we're not sure what we learned from this. But the interesting thing is, we did see significance with market rate projects. So then it begs the question, well, why are we seeing a difference there? And I don't know the answer, but one thing, we had no significance for anything, but we had significance for one class of projects, but not for ASIC projects. Now, again, we only had 85 ASIC projects, but normally longitudinal data looking at the same block groups over time with many months of observations and lots of controls for changes in population, we still didn't see it. And that was a little surprising, that we didn't see any perturbation at all. Yeah, Gil.
2 questions. I wanted to kind of veer away from data, but the first one will be a little bit. Have you guys considered using the Lotus data, the OD metrics of commuters around to compare it?
Yeah, so the loads data give you the information about
kind of the W2 kind of information.
Yeah. One of the reasons why, so I'm gonna answer your question by referring to one of the tasks. One of the tasks was looking at the question of housing size. It turns out you can't look at housing size except by pretty much there are very few data sets that you can look at housing size with. And so we ended up looking at the American Housing Survey, and Sieva led this part of the analysis. And the problem with looking at the American Housing Survey, for those of you who know the American Housing Survey and how it varies from travel surveys, is very simply, it's only got the commute. And that's the problem with loads. It's that
on the commute.
Yeah, it's just, the commute is so insufficient as a measure of travel because something like 85% or 90% sometimes of VMT is non-work. And so then we're not really doing a VMT model at that point. And so that's one reason why the results from that task are a little bit unsatisfactory because we're only able to look at commute.
Now the question that is more philosophical, it's about the motivation of your sponsors. And maybe that's the impact on the results too. When you create a new sub-development for low-income people, which will create much better accessibility and opportunities, they will drive more and it's good.
So, so your question could be reinterpreted as a question about why we're looking at VMT as something to reduce in the first place.
For this, specifically for
or even specifically for people who are low income.
Low income, yeah, exactly.
Yeah. So yeah, I mean, I don't have a good answer to that. I would say that we do care about the environmental impacts of development. What we are comparing is low-income households to low-income households. So all we're looking at is the differences cross-sectionally or over time, ideally, but cross-sectionally in HTS data between low-income households in different places. So you might think, oh, well, but what that data are showing is that you don't get out of the house as much if you live in a high-density place and you're worse off. Now, if you're right about that, then that's a problem. I don't know, I don't have an a priori reason to believe that that's actually what's going on. I think that's probably not what's going on, but it's really important to point out that travel benefits people and people driving do it because it benefits them. And I don't want to push that under the rug at all. Nevertheless, we also have this other goal, which is to not drive as much. So there's, these things are intention. Absolutely. That's the best I can do, man.
I guess that's why it would be great to be able to differentiate between personal miles traveled and VMT, because we do want maybe I don't know, like if miles would be the thing.
Well,
because you want people to get to things, but not necessarily.
You're bringing up, I want to clarify something. You're bringing up an issue which is not the same. So the issue that you brought up with the phone data is just overall travel. Right. And so what you're saying is, well, what we should be thinking about is the overall amount of time people spend traveling and control for, look at VMT, but also look at, are people still getting out and getting to things? And are they making fewer hospital visits? Are they making fewer medical appointments in places where they're also having lower VMT? That sounds like I think that's a great idea. You should do that. What's your dissertation on? You should do that.
No.
Oh yeah, it's connected to gender. You should totally do that. That's what you should do. Let's talk. Seriously. But yeah, VMT might be might be a measure of benefit primarily, you could say, but I think a better measure of benefit would be, well, are people, the UK understanding of this is the notion of kind of social isolation and how it relates to travel. And that is a really helpful way of thinking about this, is that it's about making it possible for people to have social contacts, and travel is one way that people have in the past at least done that, if they don't do it as much today. Yes, I saw your hand up.
Well, I was just sort of thinking about going back to the motivation, and were they thinking about VMT as sort of a proxy for like exposure to pollution? And was this like we're trying to not expose low income people to pollution thing? But
No, although that topic that you're bringing up of VMT as a measure of exposure to pollution is an issue, right? It's an issue in some of these dense areas. So no, I think the motivation is pretty straightforward. Cap and trade is being used to to help subsidize housing, and the ostensible rationale for that was that housing projects of this under the ASIC program are going to reduce greenhouse gases. That's all. And VMT is just a proxy for that. It's not even a measure of that, right? Because under the right conditions, VMT might not have very many greenhouse gases at all.
yeah, but I just wasn't sure if this was like a sideways environmental justice attempt or not.
I not as far as I know. I mean, I think some of my colleagues might be on the Zoom right now. They might be able to speak to that, but I don't want to put them on the spot. But no, whether it was or not doesn't matter to me, because what I'm doing is I'm trying to calculate VMT. Like I said, I'm doing some math, right? I'm trying not to let the math get affected by whatever I think is the answer or not, which is why I keep on putting up that coefficient, the rail coefficient. Which for those of you who know me, you know that I have a paper called "Does TOD need the T?" and the answer is no. So, but this suggests that maybe it does.
All right, some questions online?
Yeah, sure.
All right, Young Sun is asking.
Oh, hi, Ansan. You already saw this last week, so I told you didn't have to come to this, but.
Well, he's got more questions.
Okay.
All right. He wants to know about criteria for project proposal to get approved for AHSC support. You seem to allude that adding parking restriction to the review could reduce VMT later. So is there discussion among the research team or a conversation with CARB or other agencies on limiting on-site parking for the hospital?
Oh, no, it's already there. It's already there. I wasn't clear. So parking is already part of the formula. We would like it to be better estimated. That's from my perspective. I can see what's being done. It's somewhat ad hoc. I think it should be better done, but it's better to have it in its current form than not to have it at all. But there's a lot of other things in the calculator that I think shouldn't be there because I don't think they're correct. So that's my take on it. But no, parking is there. What's bothering me is that parking is not integrated into this method. And that is something that I want to fix in this next round of work, is to actually integrate it more.
Julia Jarasmenko asks, are there recommendations from your research for the upcoming split of the AHSC program that should be implemented in a new split version of the program, or for rewriting SB 375 for the future regional transportation?
I just heard about the split, I think yesterday or the day before. I don't quite understand it. I will be continuing to talk to folks at CARB about it and try to be helpful in that way, but I'm not exactly sure if I understand how that's going to work. It's a pretty inside baseball question. Yeah, okay.
Is there variation among the people who are living in the AHSC developments in terms of income? So the question is asking whether you would normalize by household income.
So yeah, we looked into this quite a bit. So the question is, what about, are all the ASIC programs the same? Do they all have the same income limits and so on and so forth? So we looked into this, and to the extent that we could figure it out, we think that there's a fair amount of consistency in two things. Number one, it tends to be below 60% or 50% of median income as being the threshold cutoff for eligibility for those projects. That's my understanding. I could be wrong, but that's been my understanding. And Sieva is the one who works in this area, and he was the one who did that kind of vetting. And then the second thing was that a very large fraction of all of the units in these developments are actually income restricted. That is to say, we don't have a lot of mixed income projects being included in this data set. So for those reasons, we thought that the best way to represent this, and I didn't even touch upon this, but to do the analysis, we had to go through every single county, find for every single county what constitutes 60% of the median income, and try to correlate that as much as possible with the income data and the NHTS so that we have a different threshold for every and household size. So that took a lot of time, and that was one of the corrections that we made in this in the last round of analysis. So, but I'm sure it's imperfect in terms of being able to represent everything that's going on in any of these projects because they will vary from project to project. I'm not sure if that answers the question, but
I think it gets there. So staying on the income question, are you comparing the VMT in the counterfactuals? Are you comparing VMT of low income folks living in the projects versus the VMT of the average low income person, temporarily?
Yes, that's right. We're keeping low income consistent, but we're using the definition of low income that is specific to each county or metropolitan area in California. So that's the comparison group.
And then I think you kind of answered this in your explanation of transit frequency with the rail, but this question is about asking, calculating the ease of access to a bus stop versus driving a car. So for example, if there's no sidewalk for a senior to walk easily to a bus stop, and if the bus stop headways are 15 minutes to another half hour.
Yeah. So there are so many questions so the question is specifically, what about access of a sidewalk to an ability for someone who needs a sidewalk to get to the bus stop? For that matter, what about someone with a disability who can't get from point A to point B without particular assistive devices or assistive infrastructure? No, we don't have any of that. I mean, we have only block group level data. And so I think the way to think about this is, these are averages that could be mitigated or changed, made worse or better by some of these other factors that are much more micro level factors. It's just that at that point we don't have good evidence about how those affect VMT, right? So in the end, I think the way to think about this is, okay, what is likely to affect how much people drive? What are the biggest things that matter the most, and what empirical evidence can we find about them? And we would try to lead with empirical evidence here, basically. And we just don't have good data on things like sidewalk coverage, for example. Although we'll get there eventually with satellite data and things like it. So my colleague Mariam Hosseini is doing good work on that. We can go home. You don't have to finish. I don't have to keep on asking. Any other questions? I'm not suggesting that we have to go home. I'm just I want to be welcoming to you all, since you're in my house and everything. Sorry.
You're in our house, Dan.
I know. I was making a joke.
Oh, is this your bike right here?
That's yours now. I thought I recognized it.
Well, if there's no other questions for Dan, then
Thanks for coming. Nice to see. Oh, I see one question.
Oh.
There's a question. Okay.
I would say I'm not as familiar with the cell phone data. How is that collected and
So the cell phone data are sold by private companies who collect it via apps.
Okay.
Yeah. In short. And there's fewer and fewer people opting into being able to have their information collected. And as a result, there's been a real reduction in the fraction of users who actually have data available. So, yeah. Okay, everyone was just about ready to go, so we're gonna let them go.
All right.
Thanks, everybody.
Thank you.
Nice to